If you've been following the world of large language models, you've probably heard the name LoRA pop up everywhere. But what's all the excitement about? Imagine being able to fine-tune massive AI models like Llama or Mistral right from your laptop, without needing a supercomputer or a billionaire's budget. That's the magic of LoRA low-rank adaptation. In this video, we'll break down what LoRA is, why it's such a game-changer for AI developers, and how you can start using it to customize giant models for your own needs. Let's dive in and uncover the secret sauce behind affordable, efficient AI fine-tuning. Let's rewind for a second. You have a giant pre-trained language model, think billions of parameters, trained on half the internet. But what if you wanted to speak your company's language, understand medical terms, or write legal contracts? Traditionally, you'd have to update all those billions of parameters. That's not just expensive, it's nearly impossible for most people. You'd need tons of GPU memory, huge compute power, and a lot of patience. Most of what the model already knows is still useful, so why update everything? This is where LoRA steps in, offering a smarter, more efficient way to fine-tune. LoRA, or low-rank adaptation, is a clever hack that changes the game. Instead of updating the entire model, LoRA suggests training a tiny, efficient adapter and leaving the original model frozen. This means you only tweak a small part of the model, saving time, money, and resources. The result? You get most of the benefits of fine-tuning without the massive costs. LoRA makes it possible for anyone to adapt powerful AI models to their needs, even on modest hardware. Let's see how this works under the hood. So, what's the secret behind LoRA? In a neural network, each layer has weight matrices. Think of them as giant tables of numbers. Normally, fine-tuning means updating all these numbers. But LoRA takes a shortcut. Instead of updating the full matrix, it approximates the change using two much smaller matrices. This is called low-rank decomposition. Imagine compressing a high-res image into a simple sketch that still captures the essence. During training, the original weights stay frozen, and only the small adapter matrices get updated. At inference, the model combines the original weights and the adapter for predictions. During LoRA training, the original model's weights are left untouched. Only the small adapter matrices, A and B, are trained. This means you're updating less than 1% of the original parameters, but you can still achieve performance close to full fine-tuning. At inference time, the model computes the output using both the original weights and the adapter. This approach is not only efficient, but also modular, making it easy to swap adapters for different tasks or domains. Why does LoRA work so well? Neural networks are often over-parameterized, meaning many directions in their weight space don't affect the output much. The most important updates during fine-tuning usually lie in a low-dimensional subspace. LoRA takes advantage of this by restricting updates to that subspace, making the process efficient and effective. It's like tuning a guitar, by adjusting just a couple of strings instead of rebuilding the whole instrument. This approach preserves the original model's knowledge and makes switching between tasks a breeze. LoRA brings several key advantages to the table. First, it prevents catastrophic forgetting, so the base model's knowledge remains intact. Second, it allows for easy swapping. Just load a different LoRA adapter to switch tasks. Third, the checkpoints are tiny, often just a few megabytes instead of gigabytes. This makes LoRA not only efficient but also highly practical for real-world applications, from startups to large enterprises. Let's see how easy it is to use LoRA in your own projects. Thanks to libraries like Hugging Face's PEFT and Transformers, you can set up LoRA with just a few lines of code. You install the necessary libraries, load your model and tokenizer, configure LoRA, and train on your dataset. The process is straightforward and accessible, even for those without deep machine learning expertise. Once trained, you can save just the LoRA weights, making deployment lightweight and flexible. Here's a quick look at how you might implement LoRA. You start by installing the transformers, PEFT, and accelerate libraries. Then, load a small model and tokenizer, configure your LoRA settings, and prepare your dataset. Training is handled by the trainer class, and you save only the LoRA adapter weights at the end. This means you can share or deploy your fine-tuned model without moving massive files around. The code is approachable and well supported by the open-source community. You might have noticed LoRA's popularity in the world of AI-generated images. Platforms like Civit AI and Leonardo AI Let artists share LoRA adapters for different styles, characters, or effects. With image models like Stable Diffusion, you can train a LoRA on a gaming GPU or even a powerful laptop. The results are instantly visible train on Van Gogh paintings, and your next image looks like Starry Night. This instant feedback makes LoRA a creative playground for artists and hobbyists alike. So why don't we see as much excitement about LoRA in text generation? The answer is simple. The changes are subtle. While image LoRA adapters can create dramatic visual effects, text adapters might just make a model more formal or add domain knowledge. These improvements are powerful, but less flashy. Still, under the hood, LoRA is quietly powering many customized language models used in chatbots, legal assistants, and more. Even if you don't see it, LoRA is everywhere in text-based AI. Companies use it to add domain knowledge to models like Llama and Mistral without retraining from scratch. Open-source projects like Guanaco use QLoRA, quantized LoRA, to create efficient, high-performing models. LoRA is the silent force, making chatbots smarter and more adaptable, all while keeping costs low and development cycles short. From AI-generated anime cats to legal contract assistants, LoRA is working its magic behind the scenes. Whether you're adapting a language model to your startup's voice or teaching an image generator your favorite art style, LoRA offers a lightweight, modular, and surprisingly powerful way to make big models your own. It's not magic, it's smart engineering. And it's changing the way we think about AI customization. Thanks to tools like Hugging Face's PEFT library, experimenting with LoRA has never been easier. You don't need a PhD or a data center, just a few lines of code and some curiosity. The open-source community is rapidly expanding support for LoRA, making it accessible to developers, researchers, and hobbyists alike. Whether you're working on language, vision, or multimodal models, LoRA is ready to help you fine-tune with efficiency. In summary, LoRA is a breakthrough for efficient, affordable AI fine-tuning. By freezing the base model and training only a tiny set of low-rank adapters, you get most of the benefits of full fine-tuning at a fraction of the cost and complexity. Whether you're a startup, a researcher, or just curious about AI, LoRA empowers you to make giant models your own. So go ahead, freeze that base model, plug in a LoRA, and see just how far a few thousand extra parameters can take you.